It's incredibly risky and I promised my parents I wouldn't do it. But today, we're going to dive into Jupiter, the largest planet in our solar system. Because if the Sun contains 99.86% of all its matter, 70% of the remaining crumbs are found here, in this world 2.5 times more massive than all the other planets in the system combined. And so large that we could line up 10 of ours in it.
At the distance we are still from the gas giant, a huge terrestrial storm cell would hardly be more than the size of a few pixels.
And it's in this world open to the four winds, without a solid surface, that we're going to dive into now. And as trying to land here would be like trying to land on a cloud, the best way to explore the mysteries of Jupiter is still to let oneself fall into it. 4 times faster than a bullet, because gradually leaving the vacuum of space with the engine cut off. Yet we start to accelerate due to the imposing mass of the giant that attracts us. Burning like a meteor, we approach the most imposing of the entrance gates, the Great Red Spot. A gigantic anticyclone that has been raging for at least 300 years, 15,000 kilometers wide and estimated to be deep. Here we are, hurtling at 621.371 miles per h in the upper atmosphere. Composed of ice clouds of ammonia, all in shades of white that easily diffuse sunlight and give the sky a color leaning towards blue. The winds at the periphery of the vortex reach 430 kilometers per hour. The terrible heat from friction and supersonic compression severely tests our heat shield. When the external pressure reaches 1 bar, the same as at the surface of the Earth, at sea level we move from the reference level of 0 altitude. The outside temperature is now minus 160 degrees. Since then, 100 updrafts have been shaking the cockpit, the sky is getting darker, the white ammonia clouds are starting to become denser and more turbulent, until gradually giving way to a brown mist of hydrosulfide and ammonium sulfide. We are now darting into a reddish atmosphere, it's minus 70 degrees, and the light is having more and more trouble getting through. Clouds of crystals, ice, water are starting to appear and the temperature has risen. It's only minus 40 degrees in the storm cell we just entered. On Jupiter, these structures can reach nearly 621.371 miles in diameter and over 62 miles in height. Everything gradually fades to complete darkness. The darkness is now occasionally disturbed by huge flashes of lightning that illuminate the inside of ice-laden clouds that are slightly bluish. The thunder rumbles through our bodies. The lightning here can be 1,000 times more intense than back home. 90 kilometers deep, the outside temperature is around 20 degrees. If one had to choose a moment to stop, it would be here. But don't expect to turn back. Given the significant gravity that prevails on Jupiter, going in is always a one-way trip. To escape its attraction, you would need to reach a speed over 124 miles h. That's over 5 times the speed of a modern rocket at takeoff. Might as well abandon the idea and keep falling into the storm. Here we are passing the point at which the Galileo probe stopped transmitting when it plunged into the giant in 1995. Everything is plunged back into total darkness again. We have entered the convective zone, where powerful currents that bring up heat from the core are tossing the hull around from all sides. Pressure and temperature keep rising, and not falling into gaseous molecular hydrogen, whose density, as the pressure reaches 100 bars, it begins to slow down. We are now only fusing at a few 3,000 kilometers per hour. With such a falling speed, in 10 short minutes, we will be 600 kilometers deep under. The pressure is 1,150 times higher than on Earth's surface, equivalent to that at the bottom of the Mariana Trench. This is the point from which even a bathyscaphe submarine, with a hull 15 centimeters thick, could see its structure betray it at any moment. But let's not be upset. If we're already dead, might as well continue. Falling more and more slowly, because at this stage, our falling speed is considerably reduced by the density of the gas that opposes our descent. Even at the speed of 300 km per hour, we would have to wait more than a day before seeing, in this total darkness, something happening. Starting from 8,000 kilometers deep, the hydrogen slowly begins to condense into a fog that becomes increasingly hot and dense, until it becomes as thick as pea soup. And somewhere around there, we are eventually going to stop falling. To start sinking into an ocean of molecular hydrogen and a bit of liquid helium. Until we reach a depth where our ship, having the same density as the mix, will start to float in Jupiter. From there to continue, it becomes necessary to use hypothetical boosters to counteract the buoyancy, which constantly tends to push us back up to this limit.
Like a cork.
The positive point is that the darkness is now no longer total. Because by sinking deeply into the abyss, we have entered a zone where the matter is now hot enough to start glowing. A bright red, then yellow, and finally white when the temperature exceeds 3,400 degrees Celsius. The downside is that such heat can melt tungsten, the metal with the highest melting point. Stuff that we find in the universe, and like our ship, and we are made of stuff that we find in the universe. But if you've been crushed and then melted, might as well keep going. Count a day and a half of travel at the speed of 300 kilometers per hour to start getting out of the ocean of liquid hydrogen. We've made a third of the way to the heart of the planet. The crushing pressure is now 2 million bars, and the temperature is twice that of the surface of the sun. The hellish conditions prevailing here have created an exotic substance. We are beginning to progress into metallic hydrogen, a so-called supercritical fluid, like our situation. Not quite liquid, not quite gaseous, it shares the properties of both while being quite deadly. It is the movements of this strange substance that generate Jupiter's powerful magnetic field. Continuing our descent into hell, the metallic hydrogen will, becoming increasingly viscous until it ends up being totally solid. Around 4 to 6 million bars of pressure. Here again, there is no clear limit. The transformations are gradual. And even if it means having crossed the L border, clearly marked between living and dead, for the third time, might as well continue digging from now on. At 300 kilometers per hour, count on another 3 to 4 days of descent before hoping to reach the outer border of the core, located 60,000 kilometers deep. This is your captain speaking. We have arrived safely. Congratulations. You are the first humans to land beneath a planet. We've reached rock bottom. The outside temperature is 30,000 degrees and the pressure is 40 million bars. You can turn your cell phones back on and not be able to reach your family, because the metallic hydrogen that looms over us is totally opaque to any form of radio emission. No one will ever know what we have experienced. Theoretical models suggest that beneath our feet lie around 10,000 kilometers of warm ice and exotic rocks, covering themselves a rocky core of a size comparable to Earth and 10 to 15 times its mass. I don't know about you, but I'm a little tired. Diving into Jupiter was probably a bad idea. Thank you for choosing Air Jupiter, a company that largely flies thanks to the Earthlings who support it. On TP, you will find under your screen a merchandise store made by the late pilot's father, and at the top to the right of your browser an emergency exit. The entire crew wishes you a good flight and hopes to see you again soon on our lines. One way.